Welcome back, students. Let us now go to section 3. More examples of quadratic equations, this time combined with other kind of techniques. These kind of problems are not too bad, and I think we already did this problem. Some more parentheses to break up. Otherwise, pretty much standard. I don't think it is particularly worthy of our class time. Let's go to next type of problems. We have quadratic equation with some denominators, but this time we have just numerical denominators, 4, 10, and 5, so that the LCD is, what's the LCD here? LCD is 20. In this case, LCD is going to be a little bit harder, but if you factor this quadratic trinomial, you'll see the same comment here. If you factor this, you're going to see things developing. Okay, let's go to part A. So what do I multiply here? 5, 10, and 4. So what's the LCD here? LCD here is going to be 20. So multiply 20 to each factor. I mean multiply 20 to each term, excuse me. And then you can eliminate the denominator before anything else. All good? No, not really. I intentionally made a mistake. Many students forget this one because this is not a fraction. Don't make that mistake. You have to multiply 20 to this guy as well, so that 20 is distributed to each term. Okay, and then let's remove the denominators. 20 divided by 5, that's 4. So we have 4 times 2x plus 1. 20 divided by 10 is 2. So we have 2 times 3x squared plus 2. And 20 times 2x, that's 40x. And 20 divided by 4 is 5. So no more denominator. Next, let's take care of the parentheses. By the way, let's align the equalities. 4 times 2 is 8. 4 times 1 is 4 after distributing. All good. Now, negative 2 times 3 is negative 6. And negative 2 times positive 2 is negative 4. All good? All right. Negative 5 times 2 is negative 10. And negative 5 times 3x, negative 15x. Did I get everything right? Please check. Stop the playback if necessary. Okay, looks like some further simplification is in order. We have negative 6x squared plus 8x. And then plus 4 minus 4 will cancel each other out. In the right hand side, we have 40x minus 15x. So that's 25x minus 10. Does it look right? Well, I cannot think straight if the leading coefficient is negative. You know, I used to make a lot of really stupid mistakes. And when I was in high school, I did all those algebra, and then everything was multiple choice. So one silly mistake, I get 0 credit. No partial credit for multiple choice. So I had to protect myself from possible stupid mistakes. And one of a cheap way to do that is to change all the signs whenever I see a negative leading coefficient. Multiply -1 to each, then I'm going to get 6x squared minus 8x is equals to -25x plus 10 like this. And then you can go ahead, because now leading coefficient is positive, it's a lot easier this way. Flip this -25 to the other side. And then 25 minus 8, so we get 17x. And then minus 10 is equal to 0. Looks like that's the quadratic trinomial we're going to end up with. Let's see, let's check. 6, 17 minus 10, 6, 17 minus 10. Yes, all the computation so far is correct. Okay, all right. Let's factor this. Okay. First coefficient times the third coefficient is -60. Factors of -60 that adding up to +17. What times what? Good luck. You have 20 times 3. We have to have negative sign here, so we have to have two different signs. So this should be positive, this should be negative, so that 20 minus 3 is +17, not -17. Multiply, you get that. So we have this. Alright, and then let's fill out these. So something times something is 20, and well, we have a prime number here, so that's the simplest. 3 times -1 can't be anything else, and this should be 2 times 10. And please check if all the computation or the multiplication is correct. Horizontally, 2 times 10 is 20, 3 times -1 is -3. Vertically, 3 times 2 is 6, -1 times 10 is -10, all good. So let's take cross multiplication. 2x minus 1, 3x plus 10 is equal to 0. 2x minus 1 is equal to 0, or 3x plus 10 is equal to 0. So x is equal to 1/2, or x is equal to -10/3. And that's going to be the solution here. Let's check. -10/3 or 1/2? Yes. Okay, we have complete solution down here. LCD, remove the denominator, break up parentheses, take the like terms, and then manipulate the standard form with positive leading coefficient, and then tic-tac-toe. Alright, there's some more problems like this, and how about this one? Oh boy, we have some complicated denominators here this time. And please check that x squared minus x minus 2 can be factored as x minus 2 times x plus 1. X minus 2, I mean. Please make that observation. Is that correct? Then it looks far more benign because we have x minus 2 and x plus 1 here. So this one down here turns out to be the LCD. So you just multiply the LCD here, x minus 2 times x plus 1. And here multiply x minus 2 times x plus 1. And then here you multiply the same thing, x minus 2 times x plus 1. Okay, all right. Let's simplify. This x minus 2 will be gone. In return, that's gone. And then we'll have to break up this parenthesis later. Now this x plus 1 will be gone, and that's gonna be gone. And we have this parenthesis to break up later. Now everything is gone in denominator, and all these are gone, and I'm gonna get just 7x plus 1. This time I don't really have to meddle with breaking up the parentheses, but let's keep it this way, at least for the time being. Alright, let's break up. X squared plus x plus 2x minus 4 is equal to 7x plus 1. Did I break up correctly? X squared plus 3x, and then 7x, we flipped over, so we have minus 4x. And we have minus 4, but flip this one over to the other side, we have minus 5 equal to 0. This is monic. X minus 5, x plus 1 is equal to 0. Therefore, setting the first factor equal to 0, we get this. Setting the second factor equal to 0, we get this. Therefore, x is 5 or x is negative 1. All good? Complete solution? All good? Actually, no. Not really. There's still one step missing. Check your answers. Okay? Check your answer. Plug in x equals to 5 to the original equation and check. Plug in x equals to negative 1 to original equation and check. See if both of them or some of them would work or some will fail. If you do it right, you'll see that x minus 1 will fail. This one will fail, and x equals to 5 will work if you do it right. And I can clearly see this one failing because of this denominator here. Plug in x equal to negative 1 and you're going to get 0 in the denominator, so that's going to fail. As for this one working, I cannot see just by looking at it. My mental math is not that good. So I'll have to actually plug in and do my computation to figure out. But this one I can clearly see. Well, what did I do here in my answer key here? Did all those and then plugged in and did my computation. Turned out okay. 2 equals to 2, that's certainly true. Now we have 0 in denominator, so we have invalid solution. Or extraneous. Our textbook author is currently using extraneous, so let's use that term. Invalid or illegitimate, those are also good terms, but the proper term for this particular textbook we are using is extraneous. Fake solution, whatever, I'll accept all those if I'm grading. As for this problem, again, please do the same thing. And do we have extraneous solution here? I don't know. Let me ask Mathematica to find out. And we have only one solution, so the chance is there is one extraneous solution here. If you do it right, you're going to get 2 solutions, and then plug those in. One will work out, and that will be 1/3, and the other one will fail. I'll leave the detail to the students. Alright, I'll say lesson 1 is completed.